Welcome back to the video here on the Unknown Coder YouTube channel, and today we are taking a look at LeetCode problem number 27, remove element. This is another very popular problem that is a little bit more difficult than it actually looks, even though there is a very simple solution for this. Some people just can't think about it or don't think about it. They like to overcomplicate things. So let's go ahead and take a look at the problem description. So obviously we're going to be given some array called nums, and this is going to have integers in it, and it's also going to give us some integer value called val. And what we want to go ahead and do is get rid of all of the elements of value val inside of nums. Now, the important thing to note is that they want us to do this in place. So that means that we are not allowed to create any new arrays or anything like that. Something else that's important here is that the order of the elements that are being returned doesn't matter. So as you see here, they can be changed. So it doesn't necessarily matter what the ordering is. This is going to come and play a little bit later. On top of this, we also need to return a value called k, as we can see down here. And this is basically going to tell our custom judge how many values to actually look at. So any of the values inside of the first k elements of nums is what is going to be checked against. So basically what we want to do is go through and find each instance of the value k, count up a number. That way we can get number k, and then also make sure we remove that element from nums and return that k. So let's go ahead and take a look at our first example. So for us, example 1 is going to have a nums array equal to 3, 2, 2, and 3, and the val is going to equal to 3. So what the output's going to look like is equal to, we can see that there's two 3s here. So the value k is going to equal to 2, and then our nums array needs to have 2, 2, and then it can be anything. So basically it could be like underscores, it could be zeros. We'll just put zeros here for now. So then it's going to check the first two values, which is 2 and 2. It's going to see that our 3s are gone. Now let's go ahead and take a look at our second example. So example number 2, we're once again going to have a nums array equal to 0, 1, 2, 2, 3, 0, 4, and 2. And the value we're looking to get rid of is equal to 2. So here we're going to get rid of 1, 2, 3 numbers from our array, and we have 1, 2, 3, 4, 5, 6, 7, 8 indexes. So in this case, it's going to be, we want to get rid of 3 values, and we have 8 indexes. So k is going to equal to 5 in this instance. And then the nums array that we're going to return needs to equal to 0, 1, 3, 0, 4. And then the rest of them don't matter. So we just have 0, 0, 0, for example. It's just going to look at these first 5 and say, okay, there's no more 2s in there. Everything is good. So this is what we're going to be trying to achieve. Let's go ahead and take a look at constraints to see if we can get any more information out of there that'll help us out at all. For this problem, our constraints are pretty straightforward. Our nums.length is just going to be between 0 and 100. So if we wanted to, we could do a 0 check to see if the length of the nums is 0 and just return it. However, I don't really think it's that big of an issue in this instance, but that is something you might want to look out for. So the values stored inside the array, so nums values may be between 0 and 50. So again, if you're wanting to maybe throw some big number at the end or replace some big number and sort it or something, you could do that. It's never going to be greater than 50. And this one's a little bit strange, but the value is going to be between 0 and 100, which if it's greater than 50, then you're not going to have anything to replace. So if you really want to, you could probably think about some way of filtering those out. But again, I don't think it's going to be that much of a worry. We didn't really unlock that much new knowledge out of our constraints. However, we do know that it does not matter which order the elements are in or anything like that, and it's only going to read the first k elements of the array. So basically what we need to do is place all of the elements or reorder the elements so that there's no values within those first k elements and only values that are valid. So we can probably do that by keeping track of the current count of elements that we want to keep inside the array, and then add any elements that we want to keep at the index, keeping all of those at the beginning, and then go ahead, and it doesn't matter what the last ones are, so we're just going to ignore those. So let's go ahead and do some pseudocode to see what I mean by this. For a pseudocode for this one, we're going to say for each element in nums, for each element in nums, while the element is not equal to val, we are going to set our nums of index equal to the element, and then we'll go ahead and increment our index, so index plus plus basically, and then finally we'll go ahead and after we've gone through all of this, we're going to just return the index, and index will basically basically be k in this instance. And the reason why this is still O of n is because we're only ever going to still loop through this once. We're not going to be doing a double loop or looping multiple times throughout the loop. It's still going to go ahead and end whenever we get to the end of all of the elements. Keep that in mind as well. Let's go ahead and take a look at our example and how this will break down. So for our example, we're going to have nums is equal to 3, 2, 2, and 3. And the value that we want to get rid of is equal to 3. So for iteration equal to 0, our index will equal to 0. And our nums of I is going to equal to 3. Obviously, 3 is equal to val. So we just continue. We do not add this back into nums. Then for I equal to 1, our index is still equal to 0. And nums of I is now going to be equal to 2. So obviously 2 is not equal to val. So we want to go ahead and set nums of index equal to 2. We also need to go ahead and say index plus plus. And now our nums array is going to look like nums equal to, it'll be 2, comma 2, comma 2, comma 3. And then now for I equal to 2, our index is going to equal to 1. Our nums I is going to equal to 2. So again, 2 is not equal to value. So we'll go ahead and set nums of index equal to 2. We'll also go ahead and say index plus plus. And now our nums is equal to 2, 2, 2, 3. For I equal to 3, we're going to have our index equal to 2, and our nums I is equal to 3. Now, obviously, 3 is equal to val. So we're going to just go ahead and continue the loop. And now this will be the end of the loop. Index is equal to 2, so go ahead and return index. And then the test runner will go ahead and look at those first two indexes. So we'll look at nums equal to 2, 2, 2, 3. Except it's only going to look at the first two indexes. So it's going to look at 2, 2, which obviously doesn't have any 3s in it. It doesn't matter what this part is, and it's going to pass. So let's go ahead and hop into LeetCode and take a look at how we can turn this into regular Java code. Back inside LeetCode, we're going to start out by creating an integer called count and setting it equal to 0. This is going to be the count of numbers we have gotten rid of. We're going to say for int I is equal to 0. I is less than nums.length and I plus plus. We could have also done this with a while loop. It's fine. And we're going to go ahead and say if our nums of I is not equal to val, then we want to go ahead and say nums of count is equal to nums of I. We want to go ahead and say count plus plus, and that is literally it. All we have to go ahead and do now is return the count. That way it knows how many to look at. So I said while the numbers aren't there, it's a little bit of a semantic change, but basically anytime our number is not equal to value, we'll just go ahead and place it. Otherwise we'll skip over it. Fingers crossed I didn't type anything like I do. Let's go ahead and submit. As we see, we get a 0 ms runtime, and it's going to be 100%. It also doesn't do too shabby for the space complexity either. And that's how we can solve the popular remove element problem here on LeetCode. If you felt this was useful or you learned something new, please make sure to like, comment, and subscribe. As always, I'm Ethan Uncoder. I appreciate you all for watching, and I'll see you all in the next episode. Have a great day, everybody.